All right, first of all, what is this? 1 plus. Would you agree that unless this thing turns negative and I don't see a single minus sign in it, this is going to be something bigger than 1? 1 plus something, all right? And it's 1 plus 1. Shouldn't it be 2? No. It's 1 plus 1 divided by, and it's this weird number that ends up being important. It's not pi. Do you know any other numbers that are like pi that go on forever and never repeat? There's e, you're right. Okay, that would be 2.718. But look at this one. You're adding 1 plus a fraction. Doesn't feel like that's going to end up being 2.718. So it's not e. There's one more important number out there. I mean, there's lots of important numbers, but you know, there's one more that high schoolers typically know. Pi, e, and then phi. I know it seems like I'm making stuff up here, but no. Phi is actually a variable that you could be exposed to in the Greek alphabet. Okay, and it's kind of like we just assign that letter. We don't use that as a variable. We use it as like pi. I mean, pi technically could be a variable. You've never thought of it that way, but it's just a Greek letter. But we never use pi as a variable. Anyway, this is just a somewhat interesting number, and it turns out to be 1.618. It's called the golden ratio. And I may be able to show you later where that shows up on the human body. That ratio, that number, shows up 52 times on the human body. And so this weird fraction is on you in 52 places. I'll give you one example. Your height, and where's my stick? Here's my stick. I have this stick that's got the golden ratio. The yellow part to the green part, the ratio there is 1.618. It's gotten a little wobbly. I got to fix that. Anyway, and this is built for my height, except I have shoes on, so I'm going to take my shoes off. Do you agree that the stick's about my height? All right. Guess what's right there? My belly button, you're right. If I told you my belly button was here, wouldn't you be like, oh, no, that can't be right? You know what I mean? So, yeah, that your belly button is at the golden ratio on you. And if it was lower, it would seem just really unusual. If it's a little bit lower, it would mean that you have a long torso. Couldn't that be a thing? Yes. Michael Phelps, for example. Short little legs, long torso. Perfect body for swimming. You got those legs to provide the motor back there, and the big long torso. You don't need long legs to get good kick. So anyway, he's got the perfect body for swimming. And does that mean just because he had the perfect body, he was going to become an amazing swimmer? No. But you put together all that hard work plus the perfect body for it. All right, so this golden ratio is this unusual value. Okay, enough about that. Let's move on. Today we have Inside Out Teddy Bears. Sweet. I know you've all been waiting for the day when you'd have Inside Out Teddy Bears on your math homework. One quote from one kid last hour. I'm going to see that in my nightmare tonight. Thank you very much. Why? Because we have inside out functions today. So let me show you what I'm talking about. There's 3 kinds that we're going to be exploring here today. One is 1 over a function. That is called an inverse of a function. That's the hard one. Then there's the absolute value of a function where you put it around the outside, and then there's the absolute value where you put the absolute value on the inside. Those are the 3 things I need to teach you today. Absolute valuing a function in 2 different ways, plus the 1 over the function. Take a look at this. The square root of x squared is the absolute value of x. I've told you this before. I'm going to remind you what I'm talking about. If I say x squared is 16, a lot of you were taught wrong. You were taught square root, x equals plus and minus 4. And those people were totally glossing over something really important. And they made kids think that the square root of 16 is 2 things. The square root of 16 is not 2 things. The square root of 16 is just 4, period. Why is there 2 answers then? Because the square root of x squared is the absolute value of x. Now, just because it happens to be in the notes that were made today, and you know these notes are made by different teachers, you can tell that I'm not the only one who says this. Okay, and if you graphed the square root of x squared, you'd see it's a v shape. Look, it's that purple thing. So then, what about y equals x? That'd be this line here. Well, we're going to be looking at equations where we'll compare what it would be if you had the absolute value of that function or just the regular function. So what's the regular function here? Y equals x. Doesn't y equals x just have a graph that goes like that? What if I absolute value that function? I think you know what happens. It makes this v shape. All right, so what happens if the function's kind of weird and it's like a curve? Then what's the absolute value? That's the harder part that I need to teach you today. All right, so I want you to start with, in just a second here, move this over. I just want a nice, from the start, nice pre-done function. Would you agree this is y equals x squared? Would you agree that if I moved it to the left a little bit, it's kind of y equals x squared, except it's been moved left one spot? Would you please write the equation for that? If you can't handle one little change, you're going to be having trouble on the test. Now, it is a while though. The test is not even next week, because remember how next week's a super short week? And Wednesday of that week is the PSAT. And so most of you guys are going to be busy taking the PSAT or having just gotten back from the PSAT, so you might be back from it. There's other kids that are taking some other tests that day because we try to like get all of the crazy testing stuff over with. So if you're not taking the PSAT, you're probably taking some other test that day. So anyway, Wednesday next week is going to be not much math-wise. So that leaves us pretty much 2 days next week. So we don't have enough time to get like reviewed up and take the test then. So even though this is the last day really of pretty much of new material, we're going to not test until not next week, but the following week. And it will be about 2 weeks from today. Doesn't that seem crazy? All right. So you have some time to learn what I'm about to teach you. So if you walk out of here today going, I did not get that 1 over f of x thing, we're not having the test for almost 2 weeks because of the weirdness of our schedule. We technically should, if the days were normal and you had school tomorrow, I could review tomorrow and then you could have a Monday test in theory. But there's too much going on to make that work. All right, so we get to kind of take it kind of slow, but today's is going to feel intense, but it's because we're going to have multiple days to review it, okay? All right, so if I took this function, my parabola that's been shifted 1 to the left, you should have said that that was x plus 1 parentheses squared. Raise your hand if you had that one right. Awesome. All right. Now, what if I wanted to do absolute value that? Well, it depends, Mr. Server. Do you want to absolute value the whole thing? Or do you just want to absolute value the x? All right. Now, I know some of you think that if I just absolute value that x, that nothing would happen. Because you're thinking, well, the thing's going to get squared anyways, so who cares if you absolute value that x? But you are going to add 1 first before you square it. So that absolute value will make a difference when I absolute value the inside. Because if you had, for instance, a -2, then it's going to turn into a +2, and then you're going to add it to the 1, it'll make 3. Do you get what I'm saying? With absolute values around it, I get 3 squared, which is 9. With the absolute values, I get 9. What if I don't have the absolute values? So I back it all the way up and I say, no absolute values. Now I put in a negative, what was that, a -2? Put in a -2. Now do you get, I'm going to have -1, and then I square it, and that's 1. 1 is quite different than 9. See what I'm saying? Okay, so it's definitely different if I absolute value it. What if I absolute value the whole thing? Will that make any difference? No, that won't make any difference because something's already been squared. It's already positive. Putting a bar's or absolute value around it is just going to force it to be positive, and it already is. See what I'm saying? So sometimes absolute valuing something doesn't even do a thing to it. All right. We may come back to this one later so you can see why you might be like, how did we absolute value one and it didn't even matter? Sometimes it doesn't. All right. We're going to make a new graph. Everybody make some space, and we're going to give you the baseball cap. Notice it's got some positive, it's got some negative, it's in all 4 quadrants. So it's a good example to use when you're doing a function like this. Is it a function? Does it pass a vertical line test? So it's a function. All right, so I know there was a spot there that almost looked vertical, and if you wanted to get super picky, you could argue that this part doesn't pass a vertical line test, but I'm not trying to make it straight up and down there. Okay, so if I wanted to do, that's f of x, the typical test question would be, what's the absolute value of f of x like this? Now, would it matter or not? Sometimes it doesn't matter, sometimes it does. I will give you a hint on this problem. For sure, it does matter. It matters. The answer will be different when I absolute value or on the outside of it like that. Now, what's f of x the same exact thing as? F of x is the same exact thing as y. So when I absolute value f of x, I'm really absolute valuing the y values. Doesn't that make sense? F of x is y. I absolute value around it. I'm absolute valuing the y values. So any y values that were positive, don't care. Because you absolute value something positive, it's no different. So what am I really looking for? Things where the y was negative, and now when you absolute value it, it won't be. So do you get the part of the graph that's going to change? Highlight it in green. Or I don't care, pick a color. Highlight it. What part of the graph's got to change? The part that was negative, where the y's were negative. So that part and that part, those parts of the graph have to change. Does that make sense to you? Because they have negative y's, and when you absolute value them, they will become positive y's. Without me even telling you, some of you are going to know what to do. Right? What do you think the final answer looks like? I know. I haven't told you. This is the stretchy part. I'll tell you in a minute. Pausing. Okay. Who thought it would look like that? Raise your hand if you figured it out beforehand. Sweet, look at that. That's awesome. You don't have to have figured it out ahead of time, but every negative y becomes a positive y. So if it was at negative 2 down here, then it's just going to go up to positive 2. So yay, you figured it out. All right, let's do one more like that. We'll make this the Jankity M. Would you please take that? And if that's f of x, figure out what f of x absolute values around the whole thing would be. It's the part where I build up your confidence right before I destroy it. This next one is tough. So I had my cell phone on without being in silent mode because I needed to get a call. Did you guys know this? This is a pretty cool feature. Let's say there's somebody who where if they call or text, you need to know. Like even if it's in the middle of class and it's gonna ding, you need to know. Like for example, let's say that your mom is going in for a heart transplant and your dad might be texting you at any minute, like, you know, like some updates or whatever, and you want that to come through. There's a way in contacts, you go to ringtone, and in contacts ringtone, you can set an emergency mode which will let that call ring through no matter what. So I'll give you an example. I shared that information with my daughter-in-law, the woman who married my son, and she's in pilot training, and there's a deal where if the boss calls, you pick up even if it's 1 a.m. because they got to go out and fly or whatever. So she has to leave her phone on all night, and every time a text comes in, it wakes her up. Every time a phone call comes in, she has to leave it on, because if he calls and she doesn't pick up, she's in trouble. So now she's got it set with this new setting where only his call, if it comes in, it'll ring. Anybody else, it's silent mode. So if you ever want silent mode with an exception, like I need to get my friend texts me because like it's really, really important, well, put your friend in that emergency mode under ringtone, go to emergency mode. It's kind of cool. All right, so here we go. How would you be able to live your life without knowing that? I hope I made your life just a tiny bit better right there. Raise your hand if you had that correct. Everything that was below has popped up above. All right, so let's move on. How about, I'm going to undo all of that. I'm going to leave this crazy M there. And if you got that right, then you're probably understanding that. So now we're going to go change it to the kind that is definitely way different. And that's where you have the absolute values around the x's. So everybody thinks that that just means, oh, same thing. Wherever there was a negative x, then those become positive. Here's where the negative x's are. And so those become positive x's, and you like reflect it back over this way. What would be the problem with that? The original would stay there. So your final answer, I'll make it in black here. Here would be your final answer. Why can't it be that? Not a function. Doesn't pass a vertical line test. So you can't just do this the same way where you find the negative x's and you reflect them across. That doesn't work. Now, do the negative x's matter? Yes, they do. So everybody please draw the negative x part in red, just so you understand that that's the part that's got to change. Now, would you agree that if I put in a -2, for instance, into this function, and I absolute value that, before the f even gets to it, it's going to change from a -2 to a +2. So it's like all those negative numbers just won't exist anymore. So the part that we just made red, just erase it. It's gone. Does that mean that the other side of the graph can't exist? No. Think of it this way. When we fed this function a -2, that should have been right here, -2. It's supposed to give me an answer, right? But it's not going to give me the answer for -2 because that doesn't exist. It'll give me an answer for +2 because it thinks, after absolute valuing it, that I told it +2. It's going to go over here to +2 and say, oh, the answer is like 6. And so it'll put a 6 there. Why? Because at -2, it thinks you put in +2. All right, how about at +3 where the answer is like -3? Well, if you put in a -3 into the function, if we put a -3 in here, -3 now, not -2, it'll think I put in +3, and what'll it spit out? A -3. So when I put in -3 over here into my function, it's going to think I put in a +3. It's going to go over and find the answer, which was -3, and it'll say that at excuse me, at -3, it should be -3. Does anybody else notice what's kind of happening here? Connect the dots. We made the Minnetonka M. Yay. The stuff that was over here got reflected over there as a way to think of it. But mathematically what happened is that when you tell the function, I want to put in -2, it'll never see it because it'll get an absolute value first, and it'll think you put in +2. And so it'll return the value for the positive one. That's why it's exact copy, except on the other side. All right, so one more, except a lot faster. Baseball hat again. If I say that this is f of x, and I want you to do f of the absolute value of x, then all the negative x stuff goes away. So grab your eraser and erase all of that. And then you copy it over. If we can forgive, I'm writing with my pencil or my finger today, not an Apple Pencil, so I'm feeling a little cavemanish, but raise your hand if you had that one right. Okay, excellent. Now, the last concept, the last melon, is where we have to do 1 over f of x. Again, another blank page, or slide off someplace where you get some room to write. Here's a function. I'm going to start this one pretty simple. I'm trying to make it peak right there. There we go. Okay, there's a function, and I want it to touch at 0. Okay. If that's f of x, remember how before I said, here, everybody guess what the answer is to 1 over f of x. Unless you've been trained in this before, I bet you that 0 persons in the room can get this answer right. Seriously. I'm going to let you prove it. You have 1 minute. Try to figure out what the right answer for that drawing would be. I'm challenging a whole room full of smart kids. I don't think you can do it. I mean, I believe in you and all those good things, but in the next 1 minute, I don't think you can figure it out. Try it. You might even get one little part right. But I doubt you can get the full answer right. Now, by doing that, by saying it that way, I took out about half the class just because you think it's impossible, so you're not even going to try. Okay, so that improves my odds that I'll be right. If I had said it the other way, like, this is easy, go ahead and do it. Well, then some of those people would be like, well, he says it's easy, I guess I can do it. You know what I mean? Kind of like that. If you believe you can, you can. And if you believe you can't, well, then you really can't. Okay, so that's part of my psychological battle with you right there. Does anybody think they have it? If so, turn it my way, and I'll do a quick check and tell you if you've got it. I'm going to pause for a second. Let me give it a try.